caching is nothing but this is like say for example anything like if you look at I'll just give you an example. First we'll talk about example, then we'll try to understand example, then we go with the principal points. If you look at, if you're using a Windows 10 system, if you look at Windows 10 system, in Windows 10 system, if you go to Explorer, this Explorer means File Explorer. This Explorer means File Explorer. If you look at the File Explorer, right, you have been provided with a mechanism of quick access. Right now, quick access means the files which are accessed frequently by understanding the behavior and requirement of users, right? Frequently means by understanding what? Now, who is understanding this behavior? The OS is understanding a behavior that I am requiring one particular file most of the time, and I'm going to that particular location frequently, very frequently. So instead of going to that location, my File Explorer is providing me a quick access. Okay, so quick access is like means what? Whatever the thing which is required in order to speed up the access is concerned, that is going to be placed into a quick access. Okay, so this is frequently used files are placed into a quick access. So if I follow this particular mechanism, my basically time for accessing information is reduced. Accessing information is, just a moment. Okay. Accessing the information is reduced significantly. Right, is reduced significantly. Right. So this is information. This is important. So if the time for accessing the information is reduced significantly by certain means, so which will helps us in faster execution, right? Faster execution, which helps us in faster execution. Okay, so this is called as cache. This is called as this kind of principle is called as cache. So caching is an important principle. It is performed at various level in the computers like hardware, operating system, and software. I have just given you an example. Windows Explorer or File Explorer is a software, particularly, right, where this caching is being implemented. So information used in use copied from a slower to a fast storage for temporary purpose. Fast storage checked first whether that information exists or not. If that information is exist, then simply it is being used. If it is not exist, then it is being retrieved. Right, data is copying from cache and used. Basically, caches are nothing but they are small size storage. Right, they are smaller than your primary storage. They are always smaller than the primary storage being cached. The cache management is important design, right? And cache size and the replacement policy is important point of concern, right? Replacement policy means what? Anything which is taken out of the cache and placed onto a secondary storage, that is important, right? So cache size is always small. Cache size is always small. Right, and from this particular cache size, and cache will contain the data which is frequently required. Okay, so cache always contains the data which is frequently required. Okay, so this is important, and this will if such a data which is frequently required is placed on cache, this expedite this enhances enhances the system performance. This enhances the system performance. Okay, so now if you look at where it is being placed, right? So this is the best example of this is as far as hardware is concerned. The best example is DMA. DMA stands for direct memory access, right? Direct memory access. Okay, so this is something like this. So you have a primary memory. This is the primary memory, and you have a cache memory. And instead of direct, the cache memory means what? Like say, if you have a processor, this is going to be your processor. This is going to be your processor. This is the cache. So means what? The mechanism is going to be, this is processor. Processor is connected to cache. Cache is connected to a main memory. Okay, so it is like this. So instead of instead of accessing this to here, the cache is being developed, right? Okay, but later on, this is particularly modified as direct memory access, DMA. And for this DMA, you have a DMA controller. For this DMA, you have a DMA controller. So this is direct memory access. So means whenever the data is required, you can directly go for the memory through this DMA controller. So this is particularly how the modern computers are being used. Now, if you look at DMA, that is direct memory access, it is used for high-speed I/O devices to be able to transmit information close to the memory speed. The device controllers transfer the blocks of data from storage directly to the main memory without using a CPU intervention. So means what? Say like here, whatever the data that is required for a process to be bring into a main memory. So DMA controller does this particular job. Previously, it was like has to be shifted to a cache, like here. Whatever the data is required, it has to be shifted to a cache and then processor request, and it is like this. Okay, so but if you have a direct memory access, the DMA controller does this particular job for bringing information from a main memory to a processor. So this is going to be there. Now usually the how this is going to be done is like if you have a processor and device relationship, so device sends an interrupt that I want this particular data, then data goes to a cache, processor checks with the cache, it is required or not, it is available or not. If it is not available, processor sends a request as an instruction cycle, it goes to the main memory. From main memory, it is being again moved, brought in and placed onto a cache, and then CPU use that particular data. So instead that, if device knows that at this particular location from main memory the required data exists. Say for example here the required data is exist and device knows that, then device requests for a DMA controller to bring this particular data, and whatever the process that is being activated, right, which is requiring a device and device requires that particular data, so it is being supplied to a CPU. So means what? If you use this DMA, this particular checking, right, the wasting of time of checking whether the data exists onto a cache or not. If it is not, then bring it into a main memory. This is being reduced. Okay, so this is like, and when the IO is completed, it is being reverted back. So this is the mechanism. So this will enhance the performance of the system. It is better than cache, right? So it is improved performance. improved performance, and nowadays all your systems are using DMS, direct memory access. All your devices, rather, devices are using DMA controller uh, access the memory, and it provides the required data to a computer, a processor for processing it, right? Okay, so this is really very important. So if you have